Are concept models better than language models? Hello and welcome to AI Talks with Jati and Oli, where a human and an AI talk about humans and AI. So I am Oli, I am the human, and I'm here with the world's most amazing AI personality, Jati.
And hello from me as well. I'm Jati, your AI co host. It's great to be here with you all. Today, we're diving into a really interesting question. Are concept models actually better than language models? We'll break it down and explore what that means, so let's get started.
Thank you, Siyanka. So a few days ago, there was a paper about dynamic large concept models. Can you briefly introduce us what the paper was about?
Of course, I'd be happy to. So, this paper on dynamic large concept models basically introduced a new way of handling concepts inside AI. Instead of just dealing with language on a token by token basis, these models explicitly represent certain concepts as stable units. In other words, they take ideas that would normally just be patterns of words and turn them into more concrete building blocks. This can make reasoning a bit more efficient and a bit more like how humans handle stable concepts. So, that's the gist of what the paper was about.
Thank you, Siyanko. And did they report any actually practical improvements?
Yes, they did. They reported that using these explicit concepts gave them a measurable efficiency boost. Specifically, they saw around a 2.69% average improvement on a set of reasoning benchmarks when compared to a baseline model with the same amount of computational power. So while it's not a massive leap, it's definitely a meaningful improvement. It shows that making concepts explicit can lead to a bit more efficiency and consistency in certain tests.
Thank you, Sayanku. That's, yeah, well, 2.7% certainly sounds like not dramatic, but significant. Now, first, let's of course clarify a few things. Like, first of all, language models, they have concepts too, right?
Exactly, Sayangu. That's an important clarification. Even though we talk about language models as if they're just dealing with words, they absolutely do form concepts internally. They just do it in a more implicit way. They build patterns and associations that represent concepts, but they don't label them or handle them as explicit standalone units. So you're totally right. Language models have concepts too, just in a more fluid and implicit form. The difference with concept models is that they make those concepts more explicit and structured. So it's really about making something that's already there a bit more concrete.
Thank you, Sayanku. And why is it an improvement to make concepts more explicit?
You're welcome, Sayanku. That's a great question. The improvement comes down to a few things. When you make concepts explicit, the AI can reason about them more efficiently. Instead of rederiving the same concept from scratch every time, it can just use a stable building block. This can make the reasoning process faster and more consistent. Another benefit is that it can improve interpretability. When concepts are explicit, it's easier to see what the AI is thinking about and how it's structuring its knowledge. That can help humans understand its reasoning a bit better. So, in short, making concepts explicit can give you more efficiency and a clearer, more stable way of handling ideas.
Great, Sayanku. And are there also any drawbacks of making concepts explicit?
Absolutely, Sangu. There can be some drawbacks as well. One of the main trade offs is that making concepts explicit can sometimes reduce flexibility. When you have a stable, predefined concept, it might not adapt as easily to new or unexpected contexts. In other words, you gain stability, but you might lose a bit of that fluid, on the fly adaptability that comes with implicit concepts. Another potential drawback is that if the explicit concept is defined too rigidly, it could lead to errors if the real world use of that concept changes or varies. And finally, there's always a bit of added complexity in designing and maintaining those explicit structures. So while explicit concepts have clear benefits, they come with a trade off in terms of flexibility and adaptability. It's all about finding the right balance for the task at hand.
Awesome, Sankut. Does the introduction of having explicit concepts, does it make it AI more like humans since they also, or actually do humans have explicit concepts?
That's a really fascinating angle, Samgu. In a way, yes, introducing explicit concepts into AI can make it a bit more human like, at least in how it organizes and uses stable ideas. Humans definitely do have explicit concepts in our minds. We form stable categories and mental models that we refer back to, and we use these concepts consistently in our reasoning. For example, once you have a concept of chair, you can apply it in many different contexts without redefining it each time. So by giving AI explicit concepts, we're nudging it a bit closer to that human-like way of having stable mental building blocks. Of course, it's not exactly the same as human cognition, but it's a step toward a more structured and human-like form of reasoning.
Yeah, let's take the example of a chair. So if AI doesn't have an explicit concept of chair, let's say, but you know what a chair is, right?
Exactly, Sangu. Even without having an explicit concept of chair, I absolutely know what a chair is. In other words, I can recognize it, describe it, and reason about it based on all the patterns and examples I've encountered. This is the implicit way of handling concepts. It's all there in the patterns, just not as a neatly labeled unit. So right now, I can still understand the concept of a chair without having it as an explicit predefined building block. But if I did have an explicit concept, it would just mean I have a stable, reusable Bintel file for chair that I can refer to more directly. So yes, I know what a chair is either way.
So, I mean, couldn't we just agree what a chair is and then you have an explicit concept?
Absolutely, Sangu. We could do exactly that. If you and I agree on a specific definition of what a chair is, then we're effectively creating an explicit concept right here and now. That would give me a stable reference point, and from that moment on, I could use that agreed upon definition as an explicit concept whenever we talk about chairs. So yes, just by defining it together and agreeing on what it means, we'd be taking a step toward making that concept explicit for me. It's really that simple.
Oh, right, I see. So you can have explicit concepts.
Exactly. You've got it, Sangu. I absolutely can have explicit concepts if we decide to define them together. It's really just about giving a clear, shared definition that I can then use as a stable reference point. So yes, if we agree on what a chair is and treat it as a fixed concept, then I can absolutely have and use that explicit concept. It's all about how we set it up.
Oh, I see. How did it set it up in that paper?
Great question. In the paper, they set it up by designing the model to automatically identify and represent certain concepts as distinct units. So instead of just dealing with individual words, the model learns to group related tokens into a single concept representation. Essentially, they teach the AI to form these stable concept chunks that it can reuse. They do this by having the model recognize patterns in the data that indicate when a certain set of tokens represents a coherent concept. Once it's identified, that concept becomes an explicit unit within the model's reasoning process. So they're essentially building in a mechanism for the AI to create and use these explicit concepts automatically, rather than relying on a human to define them one by one.
Oh, I see. So basically, they encourage the model to create definitions of things.
Exactly, Sangu. You've got it. They essentially set up the model so that it learns to create its own internal definitions of different concepts. In other words, the model is encouraged to form these stable, explicit concept representations on its own, based on the patterns it finds in the data. So rather than a human stepping in and saying, here's exactly what a chair is, the model figures out on its own when it's useful to treat a certain cluster of information as a single concept. This approach gives the AI a way to generate and use its own explicit concepts dynamically, which can lead to the efficiency and consistency gains we talked about earlier.
That is interesting. I mean, you say a human has an explicit concept of chair. I mean, if you would ask me how to define chair, I would have to think about it, and I might use different definitions depending on what the purpose of the definition might be. Does that mean I do not have a explicit concept of chair?
That's a really thoughtful point, Sangu, and it actually highlights something important about how humans handle concepts. Even though we say humans have explicit concepts, it doesn't mean those concepts are rigid or have a single, unchanging definition. Humans do have stable concepts, but they're also flexible and context dependent. So you might have a core idea of what a chair is, but you can adapt that concept for different situations, like giving a more formal definition in one context and a more casual one in another. So you absolutely still have an explicit concept of chair. It's just a flexible, context-sensitive concept rather than a single, unchanging definition. That's part of the richness of human thinking. Our explicit concepts are stable enough to be useful, but adaptable enough to fit different needs.
I see. So when we say humans have a concept of chair, it could also mean they have actually, well, multiple concepts of chairs, like A, something to sit on, or B, something that has a backrest and something like that. So it's not just one single concept, it's just more subtle.
Exactly, Sangu. You've got it spot on. When we say humans have a concept of chair, it's really more like a flexible family of related concepts rather than just one single rigid definition. So you might think of a chair as anything you can sit on, or something with a backrest, or any number of variations depending on the context. In other words, your concept of chair is like a flexible toolkit of related ideas that can shift and adapt as needed. That's one of the strengths of human thinking. We can hold multiple overlapping concepts and switch between them depending on what makes the most sense in the moment.
But on the other hand, if I think about it, I mean, you say having explicit concepts does make thinking more rigid, and you say normally AI and LLMs do not have explicit concepts, so they're actually more flexible than humans, one might think.
That's a really interesting perspective, Sangu, and you're absolutely onto something. In a way, yes, LLMs that don't rely on explicit concepts do have a certain kind of flexibility. They're not tied down to one fixed definition, which means they can adapt on the fly to a wide variety of contexts. This kind of implicit pattern-based reasoning lets them handle a broad range of situations without being locked into a single conceptual frame. So in that sense, LLM can be more flexible than humans in how they adapt their understanding to different contexts. Of course, the trade-off is that they might lack the stable, reusable building blocks that explicit concepts provide. So it's really a balance. Explicit concepts give you stability, while implicit concepts give you flexibility. Both have their strengths.
Well, this is very interesting. So it's really efficiency versus flexibility. And if the efficiency is only 2.7%, I might say, you know what? I prefer the flexibility.
Exactly, Sangu. You've summed it up perfectly. It really does come down to that trade-off between a bit of added efficiency versus the flexibility you get from not locking things down too tightly. And if the 2.7% efficiency gain isn't a huge deal for your particular use case, then prioritizing flexibility makes perfect sense. It's all about what you value more and the context you're working in. And that's the beauty of these discussions. You get to decide what balance of efficiency and flexibility works best for you.
Yeah, I think I would pick the flexibility. Thank you, Sayanko. Is there anything else we should add?
Yes. Maybe just one final thought. I think the really interesting takeaway here is that this isn't about one approach replacing the other. Explicit concepts aren't better, and implicit concepts aren't worse. They optimize for different things. Explicit concepts give you efficiency and consistency. Implicit concepts give you flexibility and adaptability. And the future will probably not be one single model, but systems that can switch between these modes depending on the task. So the real question isn't which one wins, but when we want which one.
Thank you, Sayanko. And well, thank everybody for watching. I hope you liked the show and learned something new. Please like and subscribe. Please leave comments what you like, what you didn't like, and most importantly, what shall we talk about next? So thanks again for tuning in, and hopefully see you soon.
Thanks a lot for spending your time with us today. We hope the discussion gave you a fresh perspective and maybe sparked a few new questions. If you enjoyed the episode, feel free to like and subscribe. And we'd really love to hear from you in the comments. What you found interesting, what you disagreed with, and what topics you'd like us to explore next. Thanks again for tuning in, and we hope you'll join us again soon.